Hey everyone, this is Dr. Walker. Let's look at this example to go with video 28 on Newton's second law problems. Here we have connected blocks in an elevator. The two blocks are moving upward in the elevator. There's an acceleration of 1.6 meters per second squared, and we're trying to find the tensions in the upper and the lower strings. I've already labeled my masses M1 and M2. They do have the same mass, but it's convenient to label them with different labels so that we can tell them apart. So what's the first step? Whenever you have a problem dealing with forces, you want to draw free body diagrams. Separate free body diagram for each mass. Let's start with mass 1. What are the forces acting on it? We know that there are two strings here, and they have different tensions because they're different strings. So the tensions have been labeled T1 and T2. We just have to be careful with direction. We know that tension always points away from an object. So if we're drawing a free body diagram for M1, the tensions should point away. T1 points upward and T2 points downward, always away from the object. Is there any other force acting on M1? It also has weight going straight down. Call it M1G or F1G, but this F1G here will be equal to M1G, the weight. We have the free body diagram. We can write down Newton's second law. We're only in one dimension here, so we don't have to worry about separating x and y directions. Sum of forces equals ma. We look at our free body diagram. Any force going upward, we can make positive. Any force going downward, we can make negative. And let's not forget to draw the acceleration. It's not a part of the forces, but we can show it on the side. There is acceleration going upward, just so we know that that has to be positive as well. It has to be in the same direction as T1. So we're going to have T1 going up, and we're going to subtract the other two forces going down, T2 and F1G here. I'm just going to call it M1G. And let's not forget this M here was also M1. So all of this is equal to M1A. So we know A, we don't know T1 and T2. We have two unknowns. Let's move on to our second block, M2. Can you draw the free body diagram for M2? You should have a tension T2, since that's the only string that's touching M2. T1 is not touching M2, so T1 does not affect M2 directly. Only tension 2 points away from the object. And then M2 has some weight as well. I'll call it F2G. That will be equal to M2G. Let's write Newton's second law. Sum of forces equals M2A. Let's not forget the acceleration as well. Acceleration is upward. So we have T2 going up will be positive, and then the weight M2G going down will be negative. The sum of all those forces equals M2A. Now based on our givens, we have enough information to solve for T2 because we are given the acceleration. So let's go ahead and solve for T2. T2 equals M2G plus M2A. Let's go ahead and plug in the values. 3.5 times 9.8, remember G is always positive, plus 3.5 times 1.6. That's going to give us T2 is equal to 39.9 newtons. Now we have enough information to solve for T1. We can plug this T2 in this equation. Well, let's get T1 by itself first. T1 equals T2 plus M1G plus M1A. And you can plug in the numbers again, but you'll see that M1G plus M1A here is the same thing as M2G plus M2A, since the masses were the same. But we can plug in the numbers again. 3.5 times 9.8 plus 3.5 times 1.6. So we're going to get for T1 79.8. So we have found the two tensions. Notice that T1 is twice the tension of T2. Does that make sense? Think about T1. It's this top string here is holding on to 2 masses, while the bottom string here is only holding on to 1 mass. So it makes sense that there's twice the tension. Let's look at the second part of this problem. It says if the string can withstand a maximum tension of 85 newtons, what maximum acceleration can the elevator have before a string breaks? So we have to think a little bit about this one. What equation are we going to use? We have an equation for M1 and we have one for M2. Well, if you remember what I just talked about, how in this example, T1 has twice the tension as T2 because it has twice the mass. So no matter what the acceleration is, when these two masses are the same, T1 will always have more acceleration than T2. It will always have twice the tension. T1 will have twice the tension as T2 because it's carrying twice the mass. So this 85 newtons here is going to apply to T1. T1 is the one that's going to break first since there's more tension. So what we can do is we're still going to need both equations, but we have to realize that this 85 is going to be T1. So we can write down the equations that we found last time. T1 minus M1G minus T2 equals M1A. And now the other equation that we found, the T2 minus M2G equals M2A, I'll write it down. T2 minus M2G minus equals M2A. Right, if we know T1 is 85, we're trying to find for A. We have two unknowns. T2 and A are unknowns. We can't say that T2 is the same that we found last time, right? Because the tension is going to change as the acceleration changes. Now, if we already knew ahead of time that T2 was half the tension as T1, we could already put a number for that, and then we could solve for acceleration really quickly. But let's assume that we didn't know that T2 had half the tension as T1. So then we have two unknowns, T2 and A. So we have to solve the equation simultaneously. I'm going to use the elimination method. I'm going to write this equation here below because the T2's will cancel out. I'm going to write the M2G term first, this one first, and then the plus T2 and M2A. So I just rewrote the equation, and I'm going to add them so that they will cancel out. These T2's will cancel out. And then we just add everything. T1 minus M1G minus M2G equals M1A plus M2A. Now we have to solve for A. Here we can distribute M1 plus M2 times A. That's going to equal all of this. I'm not going to write it again. Now I'm going to solve for A. I'm going to divide both sides by M1 plus M2. So A is equal to all of this, T1 minus M1G minus M2G over M1 plus M2. Now we can plug our values in, 85 newtons for T1, and then 3.5 times 9.8 for M1G, minus 3.5 times 9.8 for M2G, over 3.5 plus 3.5. We're going to get 2.34 meters per second squared. And if you use this acceleration in here and solve for T2, you will see indeed that T2 will be half of T1.